So week 8, and honestly, from now until the end of the course is a relatively relaxed period because um, we have kind of these like lectures here, these like requirements lectures, and they're all quite tame. They're all quite straightforward, very theoretical. We don't really have to do any coding today or anything like that. And in general, there's not much coding left for the rest of the course. That doesn't mean, of course, that there's nothing important to do, because there is still lots of important stuff to do, but we just take the coding pressure off because we know there's like a lot of coding pressure in the early weeks, right? So today in particular, we're going to be talking about iteration 3, how to get set up for iteration 3, and then we're also going to be talking about requirements. So today's lecture, first lecture on iteration 3, there's nothing really to this lecture slide deck. It's just let's get started helping you out with iteration 3. So all we're going to really be doing here is actually take a look at the spec, and we're just going to step through the spec a little bit slowly, and in particular look at a couple of small details. So this spec was rolled out to everyone on Saturday night. There was a couple of small tweaks since then, but broadly it stayed the same. And if we just kind of go through it slowly together, you'll see that iteration 0, 1 and 2 are all now done, and we're moving on to iteration 3. This iteration is called completing the life cycle. It's where we finish off the project and we do a few things that kind of set us up as if we were going to do more work together on this, but thankfully we're not. Let's have a look at what we're asking of you in this iteration. So firstly, the task. Very similar to last time. Thankfully, iteration 3 is probably the easiest transition iteration in terms of like 0 to 1's quite a step, 1 to 2's quite a step, but 2 to 3 is not that big a step. We ask that you adjust to feedback and other comments that your tutors have made during iteration 2. We want you to implement the rest of the Express server as well as the tests. It's going to be auto-marked. We want it to be persistent. We want you to lint your code. A new thing, I'll make some notes of new things as we go here. We will be testing your code coverage for iteration 3, so that's one thing. You can structure your tests how you want. We'll provide a front end just like iteration 3. There's more instructions and stuff here, and ensure that you manage sessions and tokens as per requirements in 6.9. So there's a new section 6.9. Okay, continue demonstrating effective project management and Git. All of this stuff is a direct copy of what you've seen before. There's no new information here, so that's all the same. And now we've got this other one, which next part, which is document the planning of new features. Okay, that's new. So it says that the full details of this can be found in 5.6. So we've got a new section to read, 5.6, and then it says we also have to deploy our backend to the cloud, and the detail of that is in 5.7. Okay, so just making some notes. 5.2, run the server, same as last iteration. Implementing and testing features, same as last iteration. There's not a lot to read there. Test coverage, this is definitely a thing. So that section we'll definitely come back to. That's pretty new. Dry run, same as iteration 2. In fact, the dry run is literally the same as iteration 2 because it's iteration 3 is just a bigger iteration 2. So there's nothing really new there for us. We just kind of be like, yep, jelly. You know, more of the same. Okay, 5.6 and 5.7, we said they're new things. This was the planning doc. 5.7 was deployment, so we will loop back to these things. Let's have a look at the marking criteria. So this iteration's marking criteria is also very similar. We have 55% of the marks for auto marking, so pretty high. Some of those auto marks are for code coverage, which we said we'll talk about. 10% of marks for the flavor of jelly. The flavor of jelly is it's a orange and mango. It's the aeroplane light jelly. It is. There you go, jelly. It's one of those like low sugar ones that's flavored with stevia or whatever they flavor non-sugar things with. The stuff that probably is fine, but everyone thinks it gives you cancer. I came back from a work event like just before this. I ran in the door. So code quality is 10%, same as last iteration, pretty straightforward. Feature demonstrations. This is essentially a bit that we've carved out for a few extra things that you have to do in iteration 3. So I'll also make note of that we can talk about marking criteria, feature demonstrations. So there's a new little 10% Git and project management. So each iteration, in the first iteration, there was like a big chunk for Git and project management. And it kind of gets smaller each time as we assume that you adjust to it. And then finally we have, we also have this requirements and design for future work. This is a new 15% as well. This is that 5.6 planning doc that we've seen. Like this. And then we have the bonus marks, right? The bonus marks are 10%. And this is one of my favorite things to give you all, because when we first kind of released this project a long time ago, we didn't have bonus marks. And I like bonus marks because for the kind of motivated and smart and keen and interested students out there, it's nice to kind of give you all a little bit of fun, you know, to play around with things. So generally what we say with bonus marks is that you can do anything you want, literally. You will get full marks on this generally if a top tier group spends about 40 hours of work across all the group members on it, right? So it's actually really hard to do, right? That's a good group, each spending 10 hours of time each. So if you're an average group, you're probably going to have to spend more time. The only way to really fairly mark this is kind of based on effort. And your tutors are pretty smart. They know how like hard things should be. So sometimes we'll have groups, they'll go do something like they'll pull in a weather API and they'll connect to it, and it'll just print it to the back end through a message. And it's like, yeah, it's pretty interesting. But, you know, like probably only took a pretty smart person, you know, maybe like a half day or a day or something like that. So it's very effort based, and we want to do that because we want to encourage people for putting in, you know, the time and energy. Now, what I want to preface with the bonus marks is that typically, from my rough count, maybe 90% of groups don't bother with this. And that's a good thing, right? Because these are hard marks to get. Like everything else in the project, everything else you see here, you will get better marks for the hour that you put in. So it's something we kind of discourage unless you as a group feel like you've done everything you can in iteration 3. Tony's asked a question, is that 10% only for iteration 3 or the whole project? It is for the whole project. So what that means is that if you score 100% in iteration 3, and then you get another 10%, it can bleed into iteration 2 and iteration 1 and iteration 0, but not other things, not your labs and stuff. Yeah. Here's the catch though, and here's the interesting part. You can get all of these marks instantly if your code is TypeScript compliant. That means that if you run the command npm run tsc, you will get the full 10% of marks. Now, why are we doing that? I would like to encourage students to try and make their code type safe this term, because it's a good thing to do, it's a good thing to learn, but I don't want to force it upon students because it can be very stressful and you're all under a lot of pressure and you're all probably very tired. But if we don't give marks to these things, no one does it. So it's kind of like a cheat. It's basically like, because making your whole code base TypeScript compliant, like type checked, probably doesn't take 40 hours. It's much less time than that. So it's kind of like, hey, if you want to kind of cheat the bonus marks and get a free easy 10%, just make sure your code npm run tsc passes. And I would expect about half the groups will do that, is my estimation. Yeah, so that's interesting. Now the marking formula I will also come back to, because that's tied to code coverage and marking formula. I'm just kind of making notes as I go here. Deployment 5.7. Just trying to wrap it all up so that as we go through the spec, we can then just hit off some of the key points. So we'll come back to that. Submissions, easy, extra features and TypeScript. That's just an elaboration of the extra feature stuff. You don't really have to worry about that. You know, it's kind of just like just an elaboration. Then we get to the interface. Well, thankfully this one's really easy to read because the interface is just an expansion again upon iteration 2. So even though it's a little bit kind of interesting, it's all kind of the same. I think there is a little bit of code here that might have been left in. I think this is all meant to be hidden from you all. Not that it's like secret, but it's just notes that I think the tutor's forgotten to remove. I'll sort that out after. But if you have a look here, you'll essentially see some new routes added, particularly for iteration 3. So for iteration 3 here, there's a new route around getting notifications. That one's kind of a bit of a challenge. We've certainly added some... Iteration 3 is not bigger, but it certainly starts to test people a little bit. There's a route to search to get some search results, so you can kind of search for a query string and it will return a bunch of messages. You can share a message, you can react to a message or unreact. That's just like Discord, Teams, Slack, you kind of get what that is. Pinning and unpinning, that's the same as well. You can send a message or a DM later on in time, so you can kind of send it in the future. And then some of the more interesting ones are you have the ability to actually start and end a stand-up period, which is essentially if you run stand-up start in a channel, what happens is for a certain length of time that you pass in, anyone who sends a message in that channel during that time, at the end of the stand-up, it all gets kind of condensed up and summarized in a message. So it's kind of like a little bot in a way that summarizes people's updates about the day. So all of this is detailed in the spec, that's why we write it there. There's the ability to reset passwords. Yep, that's interesting. There's the ability to upload a photo. We say upload a photo, but it's actually kind of a cheat because we just ask that you provide an image URL. So it's actually pretty easy, all things considered, but it's how like you give someone a profile photo. There's getting stats for a particular user. There's getting stats for all the users. And then there's playing with like global admin permissions as well. So a fair few things, but what's really good about iteration 3 is it's set up in a way that your team can actually divide and conquer a little bit easier. So you are more able to go and break this up into your group and just all go and work on separate things a little bit. And I'd probably encourage you to approach it like that. So when you do sit down with your group, go look at this workload, go figure out as a group how hard things are. One thing that could be really good is if you actually kind of maybe like assign points, like a score for each route or a series of routes or all the workloads, and then like assign points to all the work you think that it is based on how much work it is, and then when you can divvy that up and essentially make sure everyone has roughly the same amount of work. So some sections here, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8 are all very similar to iteration 2. Well, they are from iteration 2. Things get more interesting in these latter ones, right? So we've got a few more here. We've got 6.9 secure sessions and passwords, basically saying that you should install your passwords in an encrypted form. There's a lot of elaboration here. We kind of butchered this a bit last term when it was added, but things have improved since then, as far as I can tell. I tried to help with some of the explanations a bit. Notifications, this is just an elaboration on what those notification routes were. Analytics, this is an elaboration on what those stats routes are. So we don't just kind of give you these random routes, we actually give you like quite a lot of information to get going. And then there's the one on reacts and stand-ups and profile image and image upload. So there's a lot of stuff here, right? These are all helpers. These aren't kind of like, don't think of these as, you know, like to-dos. This is all written here and it's expanded over time because we were like, well, let's try and elaborate a bit just to help them out. So lots of helpful stuff. Go read that. Due dates, all the same. Submissions, all the same. Individual contributions, all the same. Auto marking, leaderboard, all the same. So before we go and dig deeper, what was 6.9? We probably already covered that a bit. Yeah, you can kind of go read that. We can always talk about this on Wednesday or next week. The other good thing about iteration 3 is because there's a good chance that your iteration 2 works for most groups, you don't really have to like, nothing's like blocking. You can kind of just ignore some things and tackle them later if you want to. Are there any questions at this point before we dig deeper and go into these like three big areas, which is code coverage, the feature demonstrations, deployment, and then the planning doc as well. Tony says the bonus mark is 60% times by 30 times by 10%. That's correct, Tony. Yep, exactly. Give you all like 10 more seconds, then we'll move on. Keep moving through this. Okay, so when we look at the marking criteria, let's just highlight some of the new things. The auto marking says that there's a new section called code coverage. And if you look down at the criteria here, it says that the mark, and it's very similar to last time. Last time was 95% of the your tests against your code times by our tests against your code. And then we did 5% for linting, you know? They were like, that was how we structured it. This iteration, it's very similar, except we've got this kind of new component that wasn't there before. Right, which is this thing here. That wasn't there before, right? That's what it was for iteration 2. Now we've added this. Now it looks really scary, but it's actually very, very straightforward. The C here, which is really, you know, the part of this that we need to focus on. The C is your code coverage. And if you aren't sure what code coverage is, it's probably because you haven't gone and watched lecture 7.1. You can go and watch that. There's a video there. Yes, it's from last term because I was sick. I'm not wearing a jumper in November. Very casual looking there, eh? Anyway, we kind of go through it in this lecture. You can go watch it. It's the exact same course. It's completely identical since we changed it in T2 of 2022. But what happens is every time that you run your test now, you should get a kind of code coverage. It's a score. And that scores from like 0 to 100%. And 100% means that you covered all your lines of code. 0% means your test covered none of your lines of code. So what we could do if we wanted to is we could just give you a score C for code coverage, but we don't want to do that. What we want to do instead is say, well, getting 100% code coverage is actually really hard, and in some cases it might be impossible. So rather than go and say you have to get 100, we actually want to say you only have to get 99. So that's where the min comes in. Because the min is saying that if you get 99, you'll actually get 100. And if you get less than 99, you'll get, you know, if you get 97, it'll be 97 plus 1. And if you get 100, then it's 101, but it mins out at 100, right? So it's essentially like a free coverage score. It goes from 99 up to 100. So you only need to score 99 to get it perfect. That's why we have it written up here, as 99% coverage gives you full marks for the coverage component. So that explains half of it. The next thing that's a bit difficult to explain is the cubic thing. Why is the cubic thing there? That is also really easy. And the purpose for that is because it's a little bit like, you know, remember in high school how everyone was getting marks between 80% and 100 sometimes, for instance, in some courses? So it was like if you were scoring 80%, you were doing like average, you know, like okay. And if you were scoring 100, you were like awesome. So what we don't want is to have a marking criteria where if someone scores 80% and then someone scores 100%, the person who scored 100% is probably doing more than 20% better. You know, like going from 80 is really easy to get for a coverage from a coverage perspective, but 100 is really hard. So how do we reflect that? We cube it, because what that means is that essentially, you know, someone who gets 100, or more specifically 1 cubed, if you treat it like 1, they get 1. If someone gets 90% coverage, they get a 72 or 73. If someone gets 80% coverage, they get like a 0.5, you know? And if someone gets like 70, you know, so it kind of goes down like that. So the purpose of it is essentially it's just a mathematical way of spreading out a very high end of marks. That's it. So that's what that cubic there is. That was fun, wasn't it? That's all there is to say on code coverage. It's all baked into the pipelines. I don't think we've kind of done anything crazy. If you have any issues, you can post on the forum, but it should all be there. We've spent a lot of time on it, and we'll continue to support that. Okay. Any questions about code coverage just before we move on and we talk about these other few things? Cool. Okay. Back to the spec. There is a section called feature demonstrations. And feature demonstrations has a few things. Some of them are easy to explain. One of them says, oh, there's a question. Rocky says, the time limit for testing will be applied, right? We sometimes need to fulfill time requirement to remove some cases. Removing test cases may result in the decrease of the coverage. Time limit for testing will be applied, yeah? We will apply the time limit. I can't remember what Juliana said it at as the top off the top of my head. I feel like it's probably sitting in the spec. 2.5. Here we go. That's it. It's 2.5 minutes. Okay, getting to the point. Yep. So the back end working with the front end is one of the things. That's good. That's easy. We get that. The bottom one's also kind of easy. Not kind of easy to do, but like easy to explain, which is like successfully deployed to a cloud provider. Now this makes sense because we did this in Lab 5 together. Lab 5 was a bit hard. Good job, by the way, to everyone for just like, figuring that out. We put a lot of pressure on you in week 5, more than we'd normally like, but honestly, it's like paid off, and everyone this term has actually done exceptionally well because of that so far. Like they really made the use of Flex Week. They're really on top of the work, so that's very exciting. Very, very glad to hear that. Thank you. For the project, we want you to now just deploy your server backend to the cloud instead of just, what would you say? Instead of just your lab. The good news about this though is only one of you needs to do it, right? Only one person in the group needs to do it. So as long as one person in your group did Lab 5 deploy, it should be a breeze. It should be super easy to get straight through it. And the rest of the marks here are for the password reset and the upload photo routes. So because those ones are a little bit more complicated, and they're also a little bit hard to automatically check sometimes, we actually just ask your tutors to check it manually. And then after your tutors check it manually, they go and like give you the mark for it. So that's what those 3 sections are. Section 5.7, highlights, deployment. There's some information here again. You can go and read that at your own time. If you haven't signed up for an account with Always Data, you might not be able to anymore. The reason I chose this provider, they're not the best, but they used to let us sign up without a credit card, which was great because that's kind of the big problem with a lot of these cloud providers. Well, it's not the problem. They got to make money, but like that's the inhibitor for us is that you used to have to enter a credit card. And I feel like after sending them thousands of people spooling up servers who never used them again, they've finally cracked onto us. So yeah, if you haven't set up an account yet, you might not be able to. But again, as long as someone in your group can, that's okay. And if no one in your group has, come talk to your tutor. We'll help you out. Matthew says, is deployment almost identical to lab deploy? Yeah, I mean, there might be like weird issues because the lab code is different to your project code, but structurally it's like identical. We're just like deploy the thing up there. So assuming there's no anomalies, it should be a very straightforward activity. Okay, and then 5.6 planning doc. So this one is quite, this is written as 15% in the project, right? So all of this here, this 15% is section 5.6 basically. And section 5.6 is planning for the next problems to solve. Basically, it's you planning for iteration 4, which doesn't exist, right? Thankfully for you, it doesn't exist. But what we want to do here is to say, you know what? We've gone and built this big project. It's got all this cool stuff in it. Password resets, sharing messages, stats, DMs, reacts, pins, lots and lots of stuff. What comes next? So we're going to ask you, and this is actually what we're going to cover in the next lecture, as well as a bit more next week, and we kind of did this a little bit with conceptual modeling last week, is we're going to say, let's understand the requirements and our needs of our users to implement the next thing, this iteration 4. And we're asking you to produce a short report, a PDF. Everyone in your group needs to contribute to this. It's just like your code. You can't have like just one person do it, right? You all need to contribute to it. But we're not asking you to do too much either. We generally recommend that you go and do it in a Google Doc. A Google Doc's great because it also tracks kind of history and contributions, which we really like. And then you can just export it to a PDF at the end. Basically, this planning PDF just needs to consist of a few different areas. The first one is an elicitation section, which is about requirements, where we want you to go and essentially interview 2 to 3 people as like target users for your application. These are users who either currently use a tool. Well, basically, these are users who currently use a tool like Beans or Slack or Discord or Teams or something like that. And we want you to record their name and their email address. That's part of the instructions. We then want you to give them a series of questions that you've written, at least 4 questions, to help elicit from them, and again, we cover this next lecture, what problems they have with the current software that they want to see solved, right? Once you've done this, we want you to just like record the answers, and then we want you to take the problems they have. Problems might be things like, I can't send my friends videos, or I always want to be able to send audio clips, but I can't, or I'm always sad that it's so difficult to create new spaces to work in. You don't want them to be like giving you really specific features. You want to focus on pain. Sometimes we call them pain points. Like what are the issues causing people pain? And then from that, you can go away and find a solution. After you've kind of learned a little bit about what the problems and the pain points are, that's when you can go and start figuring out use cases. And again, we will talk about this in the next lecture, so I'll be quite light on it. But it's basically breaking down who this customer is and how they actually use your product, or how you might want them to use their product on this like new features that you're trying to develop. We then have validation, which is at the end where we say, well, now that you have told us what you want, or told us what your problem is, and I've come back to you with some solutions and some use cases of how these solutions might work, I'm going to give this back to you, take it back to the people you interviewed, and be like, is this okay? Is this not okay? You tell me what you think, right? So it's like you're kind of completing the circle there. And then the last 2 pieces here are design elements, where we want you to actually design the interface. Now, I want to be clear. This is not designing the user interface. This is designing the like route interface, like in the spec, how we've got like an interface table. So we just want you to be able to come back and be like, yep, so to implement this thing, like this whole, I want to be able to send audio clips, I'm going to create a new route or modify a current route. It's post, get, put, delete. It takes in this, it returns that. That's it. You go and do that. You write that down in the doc. And then the last one is that we want you to try and conceptually model what you're doing a little bit. So that means that now that you maybe have the interface design, go and draw some diagrams. Probably state diagrams are the easiest for most things that people will find to do. And essentially just draw it out, circles and lines, and give us a sense of how it works. Now, if a state diagram doesn't work exactly, you can do another kind of diagram. I'm not too fussed, honestly. I just want to see that students are able to like identify problems, come up with solutions, validate those solutions, design an interface for it, and then visually articulate kind of how it works, right? That's the purpose of this section of iteration 3. Dylan says, for the demonstration, do we go through the implementation of our functions on the front end? Yeah, so I'm not too sure what you mean for the demonstration. Sorry, actually. I'm not sure what your question means, Dylan. Sorry. So that's iteration 3, right? I know we just spent 25 minutes talking about it. But there's a little bit to unpack, and in this lecture, there's actually a few different parts of the lecture that I've also included to kind of give you a little bit more background as well. So we'll kind of go through that quickly. That'll take us another 15 or 20 minutes. There is a little bit of code here. Sorry, I should have pulled up VLab beforehand. I forgot that I added lecture. So we've added more stuff. We're always adding stuff to this course to help out students and make their lives easier. Yep. Cool. So great. Now, first thing, stand-ups. We talked about stand-ups. Now, the funny thing about stand-ups is that the way they're structured is like they kind of start and they run in the background. Now, again, I'm not showing you how to do it, but I'm giving you some of the fundamental tools that you might need to solve it. And if you look in the code 8.1 timeout, you'll just see it in the lecture slides. You can go look up the lecture slides anytime. It actually shows you that there's a function built into JavaScript called setTimeout. And what setTimeout does is it takes in a function, and some of you might have used this for the persistent stuff already, but it takes in a function, and what it does is it says that it will execute that function after this many milliseconds. So in this case, if we set the time as 3 times 1,000 is 3,000 milliseconds, which is 3 seconds. So I've just multiplied it by 1,000. But if I kind of look at this code, let's pay attention to the order that the console logs happen in, right? npm run ts node source 8.1 timeout. Matthew says, is this similar to async and await? Look, at a really broad level, yeah, but also not really. But you can see here, pay attention to what's happened. Line 2 executed, and then line 3, 4, 5 here didn't execute. Line 7 executed the hello, and then it printed stand up is over. And if you weren't paying attention like me, watch again, because you notice that it will take 3 seconds. See? Printed those 2 lines instantly, and then 3 seconds passes, then it calls this function. So this is an exceptionally good way to, you know, I don't know how I'd put it. Like, it's a great way that you can go and delay the execution of code very easily and safely, right? It works really well for stand-ups. You don't have to worry about instances where the server might have died during a stand-up. Generally, it's safe to assume that the server runs the whole time. But that's the stand-ups. That's a big hint for the stand-ups. The next one, which has a few hints, which is the storing images. So the route for iteration 3 on image upload, it basically takes in an image URL, and then it takes in a bunch of 2xy coordinates that tell you how to crop it. So it's essentially a download an image from the internet via a URL and then crop the image. And I'm just going to show you a couple of quick libraries of how to deal with that. So the first one, and they're broken up like this, right? We're going to help you serve an image from a folder on the server. And so I'm going to kind of do this backwards. And then we're going to show you how to collect and store an image. The first thing is that if you have a really simple Express server like this, you can actually add a line here, which is app.use. And what app.use will do is say, you know what, if anyone tries to access my server /static /something, then go and give them, I don't think I have a /static here anywhere. I should create a folder. Then what I want you to do is I want you to go and give them all the any file inside the static folder. So in theory here, if I go and say, I might be doing this in the wrong folder. Let me make a folder called static. And then inside of here, I'll say like hello.txt, and it'll just say hi, right? If I go and start up this server, and I'll probably get the foldering wrong. What this is saying is that, got to open a browser now. if I navigate to localhost 3001 /static /hello.txt, I get that file. Because what it's done, according to the code, is it said, hey, anyone who accesses /static should go look for the file in this folder. And that's really helpful because that means that, say, inside the static folder, if I make another folder called like test, and then inside a test, I make a file called like hello.html, and I make, I write a little big HTML page like this, that now when I start up my server, it's kind of like the server has just become a file server at this point. And this is really, really useful when it comes to serving images that people upload, right? So that file still works, but if I go to test / what did I call it? hello.html, it says hi. So it's kind of like this entire folder and all the files in it are just exposed now on that /static route. So that's super, super useful. Express makes that really easy and powerful. You can follow that link there. But the second part, and the more interesting part, is the actual collecting and storing of an image. And again, I'm going to give you a sample of code here that's a massive help. It's more code than you would have gotten a few terms ago, but I think it's worth it to kind of help you guys along. So if we have a look at this file here, we've got this library that we've seen before, this sync request library. That's how we said we would test things, test making HTTP request to your Express server. We're actually going to use it now and flip it on its head by just simply getting an image off the internet. So what I'm saying here is I want to make a request, and I want it to be a GET request, and I want to get that particular URL. And this is just an image I found off the internet, right? It's just an image that is just this cute giraffe, right? One thing you'll notice is that the image does not have an HTTPS, or it does. Well, actually, it does. Hopefully it'll work. Generally, if you find an image that's just HTTP, that will sometimes be better. Sometimes the servers reject these requests, but it's pretty similar. I say, well, make a request, get request, here's the URL of the image, and then I say, well, the body of the image is just request.getBody. So if I try to console log that, it's going to be a whole bunch of garbage, right? But it's the image data. So if I try that now, npm run ts node source 8.1 pull image, it's going to be a bunch of garbage. Yep, so that's a bunch of like buffer binary stuff. But what we can do is that we can actually say, well, now that I've downloaded that image from the internet, I would like to write that image to the folder, say static /test.jpg. You could call it anything you want. To this file, write this data, and then I add those flags there. And now what I've got is a two-step piece where this is like get the image from the internet, and this is save it to the file system. And this is really interesting because what this means, if I look at my static folder here, you'll see that I just saved test.jpg, which is that giraffe. So now someone's kind of given me that URL, and then if I'm running the server like we saw in the last example, that means that if someone now goes and accesses, that's the wrong thing, sorry. If someone now goes and accesses static /test.jpg, they'll actually get the giraffe. And this is no longer from the internet. This is stored on my server, and I'm now sending it on that server. So again, I've actually given you like 100% of the code that you need to do most of that. The only part that's missing here is that I haven't shown you how to do any of the image cropping. Again, part of this iteration, like a lot of what we do in software, is learning how to do a little bit of independent research, to do a bit of Googling. There is no computer science around cropping an image. There is simply looking for a library that you can npm install that will be appropriate for you. Sending emails for the password reset is generally considered one of the more challenging parts of this assignment. It's a very open-ended activity. It's not a massive part of the marks, like, it's probably 2.5% of iteration 3 or something like that. So we're not trying to kill you with it, in terms of a workload, but we don't want to spoon feed you everything because we kind of spoon feed you a fair bit already. So this one is kind of like an open-ended one that's like, go and figure out how to see if you can send an email from your server. Yeah, it's a bit of a fun challenge activity. Any questions at this point? I'll just do a really quick pause before we kind of keep finishing off this lecture. So last couple of slides here. First one is Express with exceptions. So I mentioned before that iteration 3 is really similar to iteration 2. One of the exceptions, though, is that in week 5 we did actually cover exceptions as a topic in the course, and now that we're at like week 8 or whatever, we need to actually explicitly, integrate them into iteration 3. And what I've got here is I've actually got a piece of code that shows you how things would be different in iteration 3 compared to iteration 2. And that is that you have to modify your server slightly. And let me just check if we did this for you. I doubt we would have, because let me just triple check. See if we did. No, we added it. That's good. We probably left it there. We probably actually just added it in iteration 2 now that I think about it. So what is going on here is that during iteration 3, when you have an error, previously you just used to return an object that was, an objective error. In iteration 3, you're going to actually throw an exception. In particular, you're going to throw an HTTP error exception that you import from this library here, and it will either be a 400 error for a kind of, an error in input, or it'll be a 403 error for a forbidden error. That'll be the difference. This app.use here is just something you have to include that allows you to actually, allows Express to catch the errors gracefully. It's kind of a little bit of boilerplate you don't need to worry too much about. But the short story is, instead of returning an error, you now throw this HTTP error object. That's the main difference with this iteration. You don't have to throw it in server.ts. You could throw it in a different file or a different folder. That's totally fine. I'll just look for Express error 1. Okay, Express. Oh, yeah. Okay. Sorry, I think I must have jumped ahead a bunch of code there. If we have a look at this, whoopsie. If we have a look at this, the problem is that if what we do is we simply just throw an exception in our code, like a new error, the problem with this is that how Express deals with it is Express just can't distinguish that between like you trying to say, oh, hey, user of my API, I need you to do something, you've made a mistake. Express actually treats it like a genuine exception that isn't handled and it thinks your server kind of crashed. So this is it kind of being like, oh my god, the server had a big crash and problem. So what we do instead is, instead of throwing a standard error, like a throw new error there, what we do is we instead throw these HTTP errors that we import. Like this. Where now, instead of throwing a new error, we just throw HTTP error with the 400, and then this magic line that we've added to our code will just gracefully catch that. So now when we run this slightly different server, and I load up go error, you'll see that we get something slightly different, which is that Express is actually figured out here to take that error that you've given it as a string and to kind of slap it in like this, which is good. Because this is something more manageable. And it doesn't appear, see how it doesn't appear on the terminal as an error? That's because Express doesn't think this is actually the program crashing. Express is just like, oh, that's just you, the 1531 student, writing code that says, hey, someone's given me bad input. So you'll be throwing exceptions for things, whatever you previously would have returned the error object for. And to tie off this example, because obviously there's a little bit here, there's one more part to it, which is the testing of it. So similar, if you'd like to test this server, you can now do what you did before, where, describe and test, and you just simply, when you do your request to something, I don't know, that this piece of code looks like it's missing something. Apologies. Let's write out another one. Let's actually just quickly write it together here. Let's imagine that you want to test for an exception. It's actually quite straightforward, because all we really need to do is just go and make the request to go error, and we can kind of have a play around with this ourselves, right? So let's say that we've got a response from /go error, and then let's just try and console log the response. let's just play around with that. So in another terminal window, I'm going to actually go and run the test. So if I run npm run jest on source/8.1 express error 2.test, this should run the test on the server that's running, right? And you'll see that one of my tests passed, which was the first one, obviously, because the first one was just checking if hello returned hello there, which it does. But you'll see on the second one here, it didn't pass, probably because we didn't put any, oh, sorry, both passed? Yeah, they both passed, but that's because we just didn't have any expect here. But what we want to say is that the go error route here, it always throws an exception. So we're actually going to say expect that the response dot status code equals 400. Or like, we could do the whole 2b 400 thing. So now this should pass because this is like a way of checking for errors, right? So in iteration 1 and 2, you checked for errors by doing checking the error object was there. In iteration 3, you're checking if the status code that's responded with is correct. Now, what is the status code? Without going too deep in it, every time you make an HTTP request, it essentially sends back a number that tells you whether it worked or not. That's the status code. And there's lots of different status codes for different things. 200 means that everything's good. 500 means that the server crashed. 400 means that user input is bad. 403 means the user is forbidden, not permission to do this, right? So in this course, we mainly focus on these two because your server will always taking an input, whether it's a token or other kind of fields and stuff. And the server will your server that you write will respond with by default, it's always actually responding successful. But when you throw an exception, you're kind of saying, well, 400 means bad input. 403 means, bad permissions. So if I look up 403, there we go. It's all here. It's all written in the spec as always. And then lastly, express with coverage. There's a few things that we installed to your project. In fact, they're already installed. You don't need to worry about this. We've just kind of included it already. So I'm not going to go through it. But basically, coverage works. The code coverage that we covered last week works with your project, and that should be totally fine. If you could leave some feedback, that would be great. It's a bit of a long lecture, but we like to spend the time really making sure that we can help you get iteration 3 done all good and happy. And other than that, please pause the video and share some feedback. Thank you.